Good. All right, so what do we got going tonight?
I sent you the email. It's odd or even.
Did you send it to David Cowan 1949 at Gmail?
Yep.
Okay. While we're waiting for it, let's talk about odd or even function.
What?
You said it's going to cover odd or even functions, is that correct?
Yeah, it's...
Okay. So I said, while we're waiting for me to get that email, let's talk about what an even function is.
Well,
and an odd function. And an example would be y equal x squared, or maybe I should say f of x equals x squared. And an example of this one would be f of x equals x cubed. Notice the even exponent and the odd exponent, just as a way of remembering them. Okay? Notice that even functions are symmetrical about the y-axis. Odd functions are symmetrical about the origin.
right.
And this page right here is what you want to memorize. It tells you everything you need to know about even and odd functions. In other words, why is x squared even? It's because if I take f of minus x, it becomes minus x quantity squared. In other words, that's what f of minus x means, is we're going to plug in minus x wherever we see x. Well, that's equal to x squared, which is equal to f of x. So we have f of minus x equals f of x. That makes it even.
All right.
If we look at the odd function, there it came in. Boy, that took a long time.
Yeah, they said
If we
it
look
must
at
have failed.
the odd function, f of minus x, well, that would be minus x cubed. Well, that's minus x times minus x times minus x. That's minus x cubed, which is minus f of x. So this designation of f of x is really quite useful instead of y. In other words, we're getting to a point in math where we're going to make pretty much every function be an f of x or a g of x or an h of x, something of x, just because that notation is so much more robust than y. Y doesn't allow you to do all these clever things that I'm doing here. In other words, you can't really define an even function in terms of y very well, because I need to be able to say what is f of minus x. That's critical in solving these.
All right.
Just one page here?
Yeah. We only have this set of problems for our homework.
I'm sorry, I didn't hear what you just last said right there.
We only had the set of problems I sent you for homework.
Okay, yeah, that's fine. Let's have a look at it here. 39 through 45?
Yeah.
Determine
46.
whether the function is even. Oh, 36. We don't have 36 on here.
46, actually. It's 39 to 46.
Oh, 39 to 46. Okay, sorry. All right. So everything I've said up until now, I would have repeated.
All right.
Just so you know. In other words, this is critical. Everything on this page is absolutely critical for doing these problems. So the question is h of negative x equal to either h of x or negative h of x? Well, what is h of negative x? If h of x is 4x to the 7th, how am I going to find h of negative x?
Negative 4x.
No, I'm going to substitute minus x wherever I see x.
Okay, so 4 negative x to the 7th.
Like that. And always use parentheses when you do this substitution. Because, for one thing, that's not the same as this. If I omit those parentheses, well, and actually it is, as long as the exponent is odd. But if the exponent was even, it wouldn't be the same. So what is minus x to the 7th power equal to?
Would it just be minus x to the 7th?
Yeah. So now we can bring that negative sign. In other words, if I want to lose the parentheses, this is what I have.
All right.
Notice what else that is equal to. In other words, h of x was 4x to the 7th. So if I said, well, what is negative h of x? I would just put a negative sign in front of that. So recognizing that that equals negative h of x, meaning that h of negative x equals negative h of x makes it odd.
All right.
There's only three scenarios. Either h of negative x equals negative h of x, or h of negative x equals positive h of x, or neither one. So those are your three cases. Okay?
All right.
All right. What does 40 say? It's just off the screen. I can't quite read it. Looks like negative 2x to the 6th?
Yeah.
What's the rest?
Plus x squared.
Plus x squared?
Yeah.
Okay. So what do I want to look for here?
If g of x is, or if it's g of negative x.
What is g of negative x? Let's find out. What is, in other words, that's always the first test to determine whether something is odd, even, or neither, is find out what g of negative x is. Okay, so tell me what to write over here.
So it would be negative 2 parenthesis x,
No,
negative x.
negative x, not x, negative x.
Yeah. Plus, or mat, what, yeah, plus parenthesis negative x squared.
All right, we'll simplify that.
So,
Let's remove the parentheses first of all on the right side.
right, so it would be negative 2x to 6 plus x squared.
What is that equal to relative to the first function?
It's equal to the same.
So that's equal to g of x, which means that g of minus x is equal to g of x. Even function. Now, what else about even functions is interesting is this is an even function and it has perfect symmetry about the y-axis. So any function that you discover is even has symmetry about the y-axis. If you discover a function is odd, that's symmetry about the origin. What does that mean? That means that if you reflect this about the y and then again about the x, you would have this part here. In other words, if you took that and reflected it about both axes, that's symmetry about the origin. So this function is even.
So what would just neutral or
Well, let's
neither
keep going.
be?
You'll see. We haven't run into one yet, but we will. The best way to explain it is that it's not either. In other words, it's only even or odd if f of minus x is equal to either f of x or minus f of x. If it's not either of those, then it's neither. Most functions are neither. So what's my test here?
F of negative x.
What's it equal to?
Negative, or parenthesis, negative x to the fourth plus 3 parenthesis x, negative x to the squared minus 2.
Okay. Simplify.
X to the fourth plus 3x squared minus 2.
What is that relative to our original function?
It's the same, so f of x.
What does that make this? Odd, even, or neither?
Would that be neither?
It's even. This is one of the cases. In other words, we're looking to whether f of negative x is either equal to f of x, which makes it even, or negative f of x, which makes it odd.
Okay.
Okay? Those are the only two cases we really are finding interesting. If it's not equal to either one, then it's neither. Here. Let's find one. There. Let's look at 43. We'll come back and do 42, but I want to do 43 since you are interested in the neither case. Now, how did I recognize it so easily? Because I have an even exponent and an odd exponent. Notice that everything else, odd, odd, odd. Even, even. So one of the things to look for is a mixture. So tell me what g of negative x is.
So it'd be parenthesis x, negative x squared plus 5 parenthesis negative x plus 1.
Simplify.
X squared minus 5x plus 1.
Now, does that resemble our original function?
Nope.
It's neither g of x, that would be g of x. Well, what would negative g of x look like? Negative g of x would just be every term with a negative sign in front of it. So that would be negative g of x. That would be g of x. And this is neither one of those. So that's pretty much it in a nutshell. It's either g of x, or it's negative g of x, or it's neither. And that's how you're going to do every one of these problems.
Mm.
All right, let's go back and do 42. Now, I might have been mistaken, but I don't think so. As to whether or not a series of odd exponents guarantees that the function will be odd. It does as long as it's a polynomial function like this. If you have something like this, well, that's not so. If it's a rational function where you have division going on, then you really have to examine it in detail to see whether or not it is going to be odd or even. I can't really tell from looking at this function that I've circled down here whether that's odd or even. Even though I have an even exponent there and an odd exponent there, that's not enough when there's division going on. When it's just a simple polynomial like this, I'm quite certain that if all the exponents are odd, you have an odd function. If all the exponents are even, you're going to have an even function. But just to make sure, let's check. Simplify.
So negative x to the fifth plus the minus 3x to the third plus x.
Is that f of x or f of minus x or neither?
F of minus x.
Well, I'm sorry, I put that in the wrong. I didn't ask the question properly. Is that f of x or minus f of x or neither?
Minus f of x.
You're right, because I can factor out a minus sign, leaving behind x to the fifth plus 3x cubed minus x, which is minus f of x. Don't need the parentheses. And sometimes that's difficult to see. In other words, it wasn't terrifically apparent that this was the negative of that. But it's really important that if you have a function and you want to find the negative of it, that you put it in parentheses and stick that negative sign in front like that and then distribute it to every single term. And when you do that, you do get this. So sometimes there's some manipulation that is required in order to recognize that, yeah, you're looking at negative f of x right there. And this step here is actually pretty helpful to factor out the negative and then replace that with what we know it to be, which is f of x. So we can see that f of minus x is equal to minus f of x. What does that make it, odd or even?
Odd.
Good. Did 43, let's do 44. Boy, we got cold weather coming here.
Yeah.
Go to school tomorrow. Make sure you wear a jacket. You're going to need it.
Yeah. I usually wear a jacket.
Okay, good. It's just that we went from really nice temperatures to where it's going to be really cold temperatures overnight.
Yeah.
It's snowing where I'm at. So what is f of minus x equal to here?
Minus parentheses f of x, minus negative f, yeah,
That's what you meant to say. Now, if I was correct, this should be odd, right? Because that's 3, that's 1. We only have odd exponents. You don't care about the constant. It's the exponents of the variables that make it odd or even usually. Okay, what is this equal to?
Minus, it's negative x to, no, it's x to the third plus.
Good.
Minus 2x minus 9.
Aha. I was wrong.
So would that be neither?
Yes. And, well, what the heck's going on here? How come? Just a second. 42 is not neither because it was all x's. There was no constant. In other words, if it's all x's and they're all odd exponents, you have an odd function. And 41 was even because if it's all even exponents and you have a constant, it's still even. But if it's all odd exponents and you have a constant, it's neither. In other words, 44 is odd exponent, but we have a constant. And if we try to make that final expression look like either negative f of x or f, it's clearly not f of x, right?
Yeah.
So the question is it negative f of x? Well, let's factor out a negative. But what's left behind is this. So far, so good. That is not f of x. So this is not either f of x or negative f of x. So this is a big fat neither. All right, well good, I learned something here. You can't just look at the exponents. Unless it's all x. Do we have to do anything to this?
No.
What is 45?
Even.
Even, exactly. How about 46? Do we have to do anything to that?
No, it would be odd.
No?
Or no, it would be neither.
It would be neither. Let's go through that one just because we have a few minutes. So help me with the rest of this.
So it would be negative x to the fifth, parentheses, plus 3, parentheses, negative x to the fourth.
Simplify.
And simplified would be negative x to the fifth plus 3x to the fourth.
Is that equal to either h of x or negative h of x?
No.
No. It's clearly not equal to h of x. And if I try to make it look like a negative h of x by factoring out a negative, and that's always the step you end up doing, Well, that is not negative h of x. So it's neither negative h of x nor h of x, making it neither. So when we don't have a constant, and in fact even if we had a constant, it wouldn't matter, add a number into that, and the fact that we have an odd exponent and an even exponent combined, automatically neither. Most functions are neither. It's rare that you have an even function. You haven't had much trig yet, have you?
No.
Well, cosine function looks like this. Only it actually goes on forever in both directions. Is this function even, odd, or neither?
Neither? No.
Is there any symmetry?
Yeah.
About which axis?
The y-axis.
Okay, that's the same kind of symmetry as you get from a parabola. And a parabola is y equal x squared, so is a parabola even or odd?
Even.
So if you have symmetry about the y-axis, you have an even function. That's the way I memorize it. Because sine of x is odd. I know you haven't had trig yet, but you will. You'll get a little bit this year, and you'll get a lot more next. But if I graph the sine function, notice that its symmetry is about the origin. In other words, if I took this sine function and I reflected it about the y-axis and then again about the x-axis, it would look like this. Right? You can kind of get an idea if you take this and flip it about the y-axis and then flip it about the x-axis, looks exactly like this. That's what symmetry about the origin means. It's the same kind of symmetry as you get from y equal x cubed. And why is that helpful? Because I know that's an odd function, because it's got that odd exponent. So I know what symmetry about the origin looks like. So when you get to trig, and you have to know whether sine or cosine are even or odd, you'll be able to figure it out. Mitchell, you have any last questions?
No.
Did we covered them all, didn't we?
Yeah.
Okay, cool. We didn't have to do this modeling with mathematics down here?
No.
Okay, that's just a quadratic. It ends up being a quadratic. Okay, I will talk to you on Wednesday at 4.
Yeah.
Okay. Am I in the right week? No, hold on. Let me go make sure I'm in the right week. Still Wednesday at 4. All right. Mitchell, have a good couple days. Don't get too cold.
All right.
Bye-bye.
Bye.